In this video, let's have sample exercise on set operations. Given the following sets, determine the result of the indicated set operations. We have the given universal set here, the set of counting numbers from 1 to 10. Now let me list all the elements of our universal set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so let's try number 1. The given problem is B intersection C. Let's list all the elements of set B first. 2, 3, 4, and 5. We have set C contains the elements 5, 6, 8, and 9. Okay, number 1 is B intersection C. So in number 1, we are going to determine the common elements of set B and set C, or the elements that are in B, that are both in B and set C. Okay, so let's find the common elements. Now we can see here that 5 is in set C and at the same time it's also in set B. So therefore 5 is a common element. Another element. Okay, it's only 5. So therefore the element of the intersection of set B and set C is 5. Okay, let's move to number 2. Let's try number 2. Okay. Number 2, the problem is A union F. First, let's list the elements of set A. What are the elements of set A? We have 1, 3, 5, 7, and 9. And set F, the elements of set F are 5, 8, and 10. Okay, so in number 2, the problem is A union F. Okay, let's find the elements of the union of set A and set F, or the element that is in set A or in set F. Okay, so first we list the elements of set A. 1, 3, 5, 7, and 9. And next, we are going to list the elements of set F that are not in set A to avoid repetition of elements. So here we are not going to list 5 because it's already in set A. So we're going to list 8 and 10. So therefore the elements of A union F are 1, 3, 5, 7, 9, 8, and 10. Okay, next, let's move to number 3. Let's have more space, so let's erase this. Okay, number 3. The sets involved are set B, containing the elements 2, 3, 4, and 5, and set E, containing the elements 7, 8, and 9. The problem is B intersection E. Okay, let's see if there are common elements of set B and set E. Okay, observe that there is no common element for set B and set E. So therefore, the result of the operation B intersection E is a set with no element, or empty set, or null set. Let's move to number 4. The problem is C minus F. Okay, so we have set C containing the elements 5, 6, 8, and 9. And we have set F containing the elements 5, 8, and 10. Now C minus F. So the meaning of C minus F is take away the elements of set F from set C so that the result are only the elements of set C but not Okay, let's try. Okay, so let's take away the elements of set F from set C. So we take away 5 because this is an element of set F. Then we take away 8 so that the remaining elements are only the elements of set C but not F. So we have 6 and 9. Okay, let's move to number 5. Let's have more space. Okay, let's try number 5. Problem is A intersection B intersection F. So let's list the elements of set A first. 1, 3, 5, 7, and 9. And we have set B containing the elements 2, 3, 4, and 5. And set F containing the elements 5, 8, and 10. Okay, A intersection B intersection F. So here we are going to find elements that are common to the three sets A, B, and F. So A and B and F. Okay, so let's see if we can find these elements. So we have here the 1. 1 is an element of set A only. It's not found in B and F. So therefore, 1 cannot be the element of the intersection of the three sets. We have 3. 3 is an element of A and at the same time in B, but it's not in F. So therefore, we cannot consider 3 as the element of the intersection of the three sets. But here we have 5. Okay, we have 5. Okay, 5 is common to the three sets A, B, and F. So therefore, 5 is an element of the intersection. Another. What about 7? It's in A only, so it cannot be an element of the intersection. What about 9? It's in A only. What about 2? It's in B only. 8 is in F only. 4 is in B only, and 10 is in F only. So therefore, the only element of A intersection B intersection F is 5. Next, let's move to number 6. Okay, in number 6, observe that there are more than one operations and observe that there is a grouping symbol parenthesis. Now, recall that when we perform more than one operations like in the four fundamental operations, addition, subtraction, multiplication, division, and then there are grouping symbols and other operation like exponent, we are going to use the gem-dash rule. So the process is just the same with the gem-dash rule. Okay, so here we are going to perform the order of operation here for these operations on sets. So first that we are going to perform is the expression inside the grouping symbol. Then next, that is our step 1. The next is the complement. The complement operation should be performed first before step 2. Okay, before performing the union, the intersection, and the difference. So the union, the intersection, and the difference is the last operation to be performed. This is step 3. And this will be performed whichever comes first. Okay? Whichever comes first. Number 3. Whichever comes first. From left to right. Okay? Okay, so therefore we have only 3 steps. Again, number 1, we are going to perform all the operations inside the grouping symbol. Step 2, we are going to perform the complement of the operation complement. And step 3, we are going to perform union, intersection, and difference, whichever comes first from left to right. Okay, let's try number 6, following this order of operation. Now, observe that, okay, the given sets here, or the sets involved are, we have set A, containing the elements 1, 3, 5, 7, and 9. Set B, containing the elements 2, 3, 4, and 5. C, containing the elements 5, 6, 8, and 9. And we have set D, containing the elements 1, 2, 3, 5, and 8. Okay, so the problem in number 6 is we have A minus B, okay, union C minus D. Okay, okay, first we determine the elements of, okay, our first step here is performing the operation inside a grouping symbol. This one, the parentheses here. And okay, and our step 2 is performing the union, which will give the final result of the operation. Okay, first let's determine the elements of A minus B. What are the elements of A minus B? Okay, so let's take away the elements of B from A. So, take away, we have take away 3 and take away 5. So, what are the remaining elements of A only? We have 1, 7, and 9. Okay, so let's continue our step 1, C minus D. Let's perform this. Take away the elements of set D from set C. Okay, so let's take away 5 and take away 8. So the remaining elements of set C that are not in D are only 6 and 9. So therefore, C minus D is 6 and 9. Okay, then from here, we can now determine the final result of the operation by performing step 2, which is the union. So let's take the union of the elements of A minus B and C minus D as our step 2. Okay, so here is our answer, or the final result of the operation. Let's take the union. Let's list first the elements of A minus B. We have 1, 7, and 9. And then let's list the elements of C minus D that are not in A minus B. We have 6. Okay, so the final result are the elements 1, 7, 9, and 6. Okay, this time let's move to number 7. Let's have more space. So let's erase first this one. Okay, number 7. The problem is the complement of set D union the complement of set F. Okay, so let's recall the order of operations. So the first to be performed is complement before the union. So therefore, we are going to do complements first as our step 1. And next, the last operation to be performed is the union. Okay, so let's determine first the elements of the complement of set D. Okay, but before that, let's list the elements first of set D. What are the sorry. Okay, let's list the elements of set D first before we answer. Okay, so we have set D contains the elements 1, 2, 3, 5, and 8. And we have set F contains the elements 5, 8, and 10. So let's perform first the complement of set D. Okay. So what are the elements of D complement? These are elements found in the universal set that are not in set D. So the elements therefore of D complement are, we have 4, we have 6, 7, 9, and 10. Okay. So next, let's list the elements of the complement of set F. So these are elements found in the universal set that are not found in set F. So we have 1, 2, 3, 4, then 6, 7, and 9. Okay, so from here we can now perform our step 2, which is we are going to take the union of the elements of D complement and F complement. So therefore, the final answer are, okay, first we list the elements of the D complement. We have 4, 6, 7, 9, and 10. And next, we're going to list the elements of F complement that are not found in D complement. We have 1, 2, 3. Okay. So 1, 2, 3 only because 4, 6, 7, and 9 is already in D complement. So this is our final answer for number 7. Okay, let's move to number 8. So this is first. Let's sub number 8. Okay, so in number 8, the the sets involved are set D containing the elements 1, 2, 3, 5, 8, and we have set A containing the elements 1, 3, 5, 7, and 9. The problem is, okay, we are going to determine the the complement of the intersection of the complement of set D and set A. Again, the complement of the intersection of the complements of set D and set A. Okay, so let's determine now the order of operations. Okay, so recall that we are going to perform first the operations inside a grouping symbol as our first step. Then after that, we are going to perform other operations like this, complement. Okay, so here, inside the grouping symbol, there are two operations, the complement and the intersection. So what operation will be performed first? Is it the complement or the intersection? According to the rule, we are going to perform first the complement. So therefore, we determine first the complement of set D. Next, we determine the complement of set A. And finally, we determine the intersection of the complement of set A, set D and set A. Okay, so first we list the elements of the complement of set D. So what are the elements found in the universal set that are not found in set D? So we have 4, 6, 7, 9, and 10. What about in A complement? What are the elements found in the universal set that are not found in set A? So we have 2, 4, 6, 8, and 10. Then finally, let's determine here the intersection of the complements of set D and set A to complete our step 1. So let's look for the common elements. We have 6 is common, We have 4 and we have 10. So the elements therefore of the intersection are 4, 6, and 10. So this is our step 1. We have completed already our step 1, the grouping symbol, performing the operation inside the grouping symbol. Next is to perform the complement, which is the final operation to determine the final result. So here we're going to take the complement of the elements of these sets 4, 6, and 10. So the elements are we have 1, 2, 3, 5, 7, 8, and 9. Okay, so let's move to number 9. Number 9. What are the sets involved? We have B, C, and D. Set B containing the elements 2, 3, 4, 5. Set C containing the elements 5, 6, 8, and 9. And set D containing the elements 1, 2, 3, 5, and 8. The given problem is take the union of B and C, then intersect it with set D. Okay, so what are the order of operations that we are going to perform here? Okay, so according to the rule, we are going to perform the operation inside a grouping symbol, parenthesis here. So this is our step 1. And our step 2 is to perform the intersection to determine the final result of this problem, number 9. Okay, so what are the elements of B union C? So these are the elements of set B, 2, 3, 4, and 5. And the elements of C that are not in B. We have 6, 8, and 9. And we can now directly perform our final operation here, the intersection, which is step 2. Let's look for common elements of set D and the intersection of B union C. Uh, we have 2 is common, another is 3, another is 5, and another is 8. So the final result are the elements 2, 3, 5, and 8. Okay, let's move to the last number. Okay, number 10. What are the sets involved? We have E. What are the elements of set E? 7, 8, and 9. And then F, 5, 8, and 10. And C, 5, 6, 8, and 9. Now the problem is the complement of the union of set E and set F intersection with the complement of set C. So what are the steps here that we are going to perform? Okay, first we perform the operation inside the grouping symbol, number 1. Next is we are going to perform the complements. As our step 2, we have 2 complements here. Step 2, and then step 3 is to find the final result of the operation, we perform the intersection. Okay, so let's perform first E union F. What are the elements of E union F? So these are 7, 8, 9, and we have 5 and 10. Then next, we perform the complements. Complement of the union of set E and set F. So these are elements found in the universal set that are not found in this set. 7, 8, 9, 5, 10. So the elements therefore are 1, 2, 3, 4, 6. Okay, that one. 1, 2, 3, 4, 6. Then, next, let's determine the elements of the complement of set C. We have 1, 2, 3, 7, and 10. Then, we can now determine the final result of the operation by performing step 3, intersection. So let's find the common elements of the complement of A union F and set the complement of set C. Common elements we have 1, 2, 3, okay, 1, 2, and 3 only. Let's check. I guess we lack one element here in C complement. We lack 4. Okay, so we have 1, 2, 3, 4, 7, and 10. Complement of set C. So the common elements therefore are 1, 2, 3, and then 4. We have 4. So the final answer therefore in number 10 are the elements 1, 2, 3, and 4.